we have discussed three things. So one is we know that what is the network fundamentals. That means how that network is connected and how the packet flows happening between these data centers and user. So this kind of thing. Second one is the devices, which data inside the data center. What are the devices we are using? That's the second thing. And third things, we know that architectures. So today we are going to see the remaining portion of the architectures, and then we'll going to see like a cablings. Okay, what are the cables and what types of cables we are using inside the data centers? Okay, and based on the cable side, what can what by what types of errors we can get. So this is what we are going to see. Let me share my screen. Okay, so we know what is two-tier and three-tier and spine leaf architecture. So two-tier is nothing but it's only we have a two options. Okay, one is core and distribution layer at the same time, and then we have a access layer. So this is a only two. There is a two persons with that. Okay, this core and distribution layer will be like a router or L3 switches or firewalls or anything. And then the access layer is a switch. So normal. The switch is connected to the end devices, physical layer. So in the three-tier architectures, we are splitting the core layer and distribution layer into the separate devices. Okay, core layer will be the router and distribution layer will be the L3 switch or something like a stack switch or something. Then access layer should be normal L2 switches. Okay, then we have a end devices. So this is three-tier architecture. In the spine leaf architectures, we are splitting the device into the spine and leaf. Okay, the spine will take care of the controlling the traffic. Leaf switches will take care of the storing the data. So that is split into the a single device is also split into the two virtual things. So next one is we need to understand like what is LAN, MAN, WAN. Okay, so first one is LAN, then MAN, then WAN. Any idea about what is LAN and WAN?
Yeah, the network which comes out from the router and gets
Hello,
connected to the.
Sam audible?
Yeah, so the network that comes out from the router
Okay.
is called as a local area network. It is generally meant for a uh, small office, home office setup. And for WAN, it is meant for wide, like bigger. It covers a bigger range, and it may it encapsulates multiple routers. When compared to LAN, the distance for WAN is bigger. But how do you
Uh,
define it is more.
okay. So let me ask you one thing. Okay. I have a one cognizant office, okay, in Chennai. And there is a one more cognizant office in US. Okay, US San Francisco something. Is it come through that LAN or WAN?
It comes through WAN.
Okay. But it's come through LAN, not a LAN actually. It's like come through MAN, but it's not a WAN actually. Why I am saying this? Okay. See, LAN is for the small area. Yeah, that's fine. And
Wait,
WAN is also for
you're saying it comes through WAN or MAN?
man. It's a metropolitan area network.
Okay.
Okay, but it's not an actual WAN. Okay, so WAN is not something a larger area only. Okay, I'll show. I'll give you. I'll give you that insert details. Okay, first coming to that LAN. Okay, it's a local area network. Yeah, that's the correct one. Okay, it supports some smaller portion. Smaller portion in the sense of it's not a area. Okay, for example. It's inside the company, that is the meaning. Okay, inside the single company, single building or single company. Okay, for example, let's say like you have a one cognizant office. Okay, this cognizant office inside the some IT park or something. Okay, so this cognizant company and this cognizant company have a dedicated application to uh, apply for the work from home or something. Okay, so that application, okay, will work only if you are in the cognizant Chennai campus. Okay, if you are in a Chennai campus, that application should work. If you are not in the Chennai campus, if you are not connected to the Chennai campus network, then the application should not work. So that application should be for the only that inside the campus if you need to be there. And same thing, okay, if you are in the cognizant Chennai campus networks, you can connect to your neighbors. That means you connect to that your friends laptops. You can easily connect to that, you talk to that friends laptop. So the LAN is not a smaller portion, it's a single company, single building company. Okay, you get my point. So it's like a, for example, inside the company you need to be there. Okay, or inside the company network. Okay, if you are using the VPN, that is also fine, but you need to be in the company network. You get my point?
Okay.
Okay, the same time if you go for the man, okay, metropolitan area network. Okay, and the same work from home application or any application, you can say like attendance application. Okay, so you're working in a Cognizant company. Okay, you need to be mark your attendance, but Cognizant have some policies. You are not supposed to be in the Chennai office. If your base location in Chennai, so you are not supposed to be here for the Chennai location all the time. But you can log in through your Bangalore office. You can log in through your Delhi office, San Francisco office, anywhere. But you need to be in the Cognizant office. That's the only rule. Okay, so that time these cognizant officers across the world will able to communicate. Okay, so that is part of the man metropolitan area network. So you need to be in the cognizant campus. Okay, but you are not supposed to. You are not like a need to. You no need to be in the Chennai office location all the time. Okay, you can log in through your Chennai office. You can log in through your Bangalore office, Delhi, Mumbai, anywhere. Okay, but you need to be in the cognizant office, cognizant network alone. That's all. So that is considered as a man. Okay, and WAN is actually it's a larger area. That's fine, but it's a different networks. Okay, it's not only the cognizant network or it is not only the any specific network. It can reach anywhere from the world, anyone from the world. For example, Facebook, Google, YouTube, this all okay. Your mobile is your dedicated networks. Facebook is a different networks. Google is a different networks. YouTube is a different network. But you can able to access if you have an internet, then you can able to access any of the application. So that is called WAN. So WAN is nothing but a internet. Okay. If, for example, MS Office. Okay, for I can say like a MS Office. So yes, previously the MS Office will work only if you are in a campus, but now it's everything in the cloud, so we can able to access anywhere, anytime. So that is a internet application. So WAN is nothing but a internet. So we have a network topology. One is LAN, which is in a smaller area. That's correct, but it's in the single company. Okay, man is a same company, but in the different location we can say. But it should be under the one single umbrella. It should be in a Cognizant campus or it should be in the TCS campus or something. Then WAN, wide area network. So it is like a internet applications. Clear? Any doubts?
Yeah, clear.
Okay. And small office and home office nothing but like a LAN. Okay, so the LAN is a different term is we are also in like a small office. Any idea about on premises and cloud? What is cloud? Any idea?
So, cloud provides computing, storage, and hosting resources to people who require them without owning them, so they can rent and do their work.
Okay. So, any idea about what is on premises?
So companies may choose to have their own uh, infrastructure like server on their location. So I think that is on premise.
Correct, exactly. So on-premises is nothing but you are owning your data center. Okay, so data center devices, etc., everything you are owning. Okay, routers, switches, firewalls, etc. Every devices you are the one owning. That means your company is owning. Okay, to change the devices, to monitor the devices, to power infrastructure security. That means no one from that stranger can access the data centers. That kind of security, physical security. So everything will take care of by your same company. So that is called a on premises. Okay, your data center is an on premises data center. Then what is a cloud? So cloud is nothing but as you said, so the devices, the whole infrastructure is owning by the different company. We are just get some portion of that, like a renting, as you said. So I'm using only the data. Okay, I am responsible for the data I am running, not the infrastructure. Okay. So how this cloud provide that? Okay. So for example, let's take a Azure or AWS. Okay. AWS or Azure. Okay. It's not providing the infrastructure to you, only you. Okay, they will provide yeah the multiple companies, n number of companies. Okay, they having the infrastructures of such a large networks. For example, you can say like we have a Google Drive. Okay, for example, every Google account will get the 15 GB storage for free. Okay, if you are pay, you will get the more. Okay, 100 GB or something. So do you think like a Google going to maintain a 15 GB hard drive? Okay, especially for you, it's not. Okay, he might have like a hard drive like 1,000 petabytes or something like some large amount of memory. Okay, so in that particular large memory, okay, once you are created the Google account, they will give you the small portion of the 15 GB of memory to your name, Eshwara's name. Okay. And another 15 GB, once you created the account, another 15 GB will be there for the Mustafa account. So this Mustafa's 15 GB and Eshwar's 15 GB will be there in the same device only. Okay. It should be in the same device. But I'm not able to access your data and you are not able to access my data. So it is split or it is virtually created by the one layer called hypervisor. Okay, hypervisor is nothing but it's a virtualization OS. Okay, so based on the virtualization only, the cloud is happening. Okay, so it is virtualized. Okay, every single portion of the 15 GB will act as a single device, but it's not a physically single. So this is how the cloud is actually work. Okay, any doubts?
No, it's clear.
Okay, and what is virtualization? Any idea?
So basically running multiple operating systems in the same computer.
Yes,
Something.
correct. But it's not only the operating system. It should be anything. Okay. Simply, I can say creating the multiple virtual instance from the one single physical instance. Okay. It should be anything like say we can able to virtualize the firewall. Okay, for example, I have a one firewall. Okay, I have one firewall. Okay, in this firewall we have a 10 ports. Okay, I have a 10 ports. Okay, but I need to virtualize that. Okay, so this 4 ports will be act as a single firewall, and another 4 ports will act as a single firewall. Then we can able to do that. Okay, so this is a dedicated one firewall, and this is dedicated for one firewall. So logically it's a two firewall, but virtually, so physically it's a single firewall. Okay, so yeah, we can able to do the same thing for the router, same thing for the switch, and same thing for the servers, etc. Okay, nowadays we can able to virtualize anything. Okay, in the so whatever. Okay, inside the IT we can able to virtualize anything. So what are, like, first one is container. What is a container here? Where it is. Okay, so server virtualization, first of all, server virtualization is nothing but one single server can able to run as a multiple servers. It's normal like a machine, like you can say like a system, whatever. We can run a multiple OS in a single system, right? So same like that. So it's physically single system. Okay, for example, this is my system. Okay, I have like a 1 TB of SSD, 32 GB RAM, and processor, etc., etc. Everything is there. Okay, so I will split the system. Okay, I will give something like a 250 GB of hard drive to the my Linux system. Okay, so 32 GB I give like a 2 GB RAM for that Linux, and then I will split into that Windows. Okay, and then I will split it into the CentOS. Okay, I can run multiple operating systems. Okay, so this is act as a single system, this is act as a single system, this is act as a single system. So but physically it's everything in the single that means one physical instance, but we can able to create like a multiple virtual instance. Okay, I also have something like a VMware Workstation Pro. So this VMware Workstation Pro is my virtualization hypervisor. So inside that machine, I will run the two machines. One is for the EVNG and one is for the Kali Linux. Okay. And previously, I have something like a 4 to 5 days operating system. Now I running the two systems. So Windows is my one system. Windows is my actual system. Okay. This is only one laptop. Okay. Inside that laptop, I have a three system. Same like a everything. Okay, so container is nothing but a container is a storage device. Okay, as the same example which I share you for the Google Drive. Okay, so that's the same thing. And last one is important is VRF. VRF is for networking. That means we can able to convert a single routers into the multiple routers. VRF means virtual routing and forwarding. Okay, for example, if I have a 5 interfaces, I can split into that multiple. Okay, I can run that single router. Okay, physically it's a single router, but it's a virtually multiple routers. Okay, where we are using the VRFs. Okay, have you know any? Have you heard of the word MPLS?
No.
Okay, so MPLS is one of the technology. Okay, we will see in this VPN section. Okay, that MPLS works under the VRF only. Okay, this ISP side they will do the VRFs and all. So that is a concept. Okay, single routers can split into the multiple router. Okay, so this is for the architectures, everything. Now we need to focus on this cablings. Where it is. Okay, so do you get any chance to visit any data centers so far?
No.
Okay, so did you see that Ethernet cables?
Yes.
Okay, so which color it is? Any idea?
You mean after splitting the cable?
Like I asked like a gray or yellow, blue or something.
So Ethernet cable is usually like dark color, black or gray or something. And if you cut it, the cable inside will have color.
Inside that cable, we have a 6 to 7, sorry, 7 to 8 color codes. Okay, that's what. Okay, we will discuss. Okay, fine. So coming to the cabling infrastructures, okay, we have a two major types of cable. One is Ethernet, one is optical fiber. Okay, so what is the Ethernet? Okay, Ethernet is nothing but it's a normal cables. Okay, which we are predominantly work inside the networking. Okay, inside that Ethernet cable, we have the 7 colors of copper cables. Okay, all that's the copper cables, copper wires. Okay, so we have another cable which is called as a optical fiber. Okay, this optical fiber cables, we have some like a something like a glass tube inside the cable. Okay, so why the glass tube? So comparing to the copper wires, okay, this glass tube can able to forward the traffic, transmit the traffic with the high speed. Okay, we can able to achieve the high speed while comparing to the copper cables. Okay, if you are using your routers or inside your home routers, you might see, okay, that is a one router is inside your home, that behind that there is a cable. It's called as a copper cable. Sorry, that's a optical fiber cable. It should be like a yellow color, or it should be like this optical fiber cable. Okay, it should be like this cable. So inside that cable, we have some glass tube. Okay, it should be like this pin. So inside that there is a glass tube. So that uplink always we are using now is a optical fiber cable. What is a uplink first? For example, if I have a switch, okay, I have a multiple ports. Okay, one is connected to router. Router is connected to ISP. Okay, so this switch will get the data from the router through this particular port. Okay, so this port is called uplink port. Okay, so where it is getting the data, that is called the uplink port. So this particular port need to be in the high speed. Okay, so for example, so this is like a 1 gig port. Okay, so other ports, okay, it's connected to the PCs. Okay, so this 1 gig, if you get that 100 Mbps speed, okay, from the data, so it will split into all the devices. Okay, so that we can use a Ethernet cable. So this is the procedure. Okay, we need to use a optical fiber cable for uplinks, and the other ports, normal ports, we can use the Ethernet cables. Okay, inside the Ethernet cables also we have a different color codes. Okay, gray color is there, yellow color is there, red color is there, and blue is there. Everything is called as a cat 4, cat 4e, cat 6e. So this all compared to the speed only. Okay, so gray color will handle something like a 10 mbps per second, and then it will increase like a color as per the color code. Okay, so inside the Ethernet cable, we have two types. One is straight through cable, one is crossover cable. One is straight through and one is crossover. Okay, what is the difference here? Okay, so as you said, okay, inside the Ethernet cable, we have some color code. Straight through cable versus crossover cable. Okay, so inside that we have 8 color codes. Okay, the side 1 and side B is actually the Ethernet cables. One side 1 means that particular one end, and the side 2 is another end. Okay, so in this straight through cable, you can see this color code is same like a side A and side B. You can see here. Okay, where it is? No. Okay, you can see the straight through cable, each side the color should be same. Okay, for example, it will start with this white with green, then white with orange, then blue. So at the same time the side B is also the same thing. Okay, but in the crossover it should be change the order. Okay, it will start with this white with orange, then it will go to the third pin. Why it need to be changed? Okay, there is a one option is there, that means a one task is there. So mainly we are using this straight through cable, sorry, mainly we are using this straight through cable for different devices. Okay, different devices in the sense of router to switch, or switch to router, or switch to PCs, or something like a switch to firewall. So this is a different devices, not like a model. It's actually the devices. Okay, but when you are using the crossover cable, we need to use for the same devices, router to router, switch to switch, firewall to firewall, something like that. Why we need to use something like that? Because every devices we have a RX pin and TX pin. RX means receiver, TX means transmission. That means transfer. So that order, that arrangement of order for that RX and TX pin would change for every device. That's the reason we need to use a straight through and crossover for the separate devices. Okay. In previously, we will get an error if we are changing the cables. For example, if we are using the straight through cable instead of crossover times, or else if you are using crossover instead of straight through, then we will get the error in the sense of that power will be there, that uplink, you will get the green signal, that means the green light and all, but the data transmission will not happen. But nowadays we have a one feature called auto MDX support. All the network devices will come up with this particular feature, auto MDX support. So since this auto MDX features, if you are using instead of the straight through to crossover or crossover to straight through, it will automatically adapt for the situation. Okay, you will not get any errors, or never packet loss should be happen. So automatically it will adapt for the particular cable. So this is a feature we are having now. Okay, so these are the cabling types. Okay, now coming to that error, what kind of errors we may get using this L1? Number one is collisions. Collision is simple. So normally we can say like a collision is getting too much of peoples in the small narrow road or something. That is called a collision. The same thing, if you are sending too much of data inside the cable, that inside the particular line, then it will happen the collisions. Okay, then it will lead to the packet loss. Number one. And number two is errors. Okay, if there isn't some issue with this port or cables, that packet loss is happen, then this errors will happen. Okay, this mismatch duplex means, again, it's an important one. Have you heard about this word full duplex, half duplex, single duplex?
Oh yeah, but I did not understand straight through and crossover.
Okay, see, straight through and crossover is simple. Okay, both are the Ethernet cables. Number one. Okay, I will show you. Where is the better cable? Yeah, you can see here. So this is the cabling type. Okay, so this is a side one and this is side two. Okay, so
Side one
straight
meaning?
through.
Side one meaning?
Side one means if you see this Ethernet cable, we have a this kind of pin in one side and this same kind of pin in another side, right?
There is only one pin on one side, right? What do you mean two sides?
How it should be? Give me a minute. I will show you on cable. I will send you that picture in WhatsApp. Okay, give me a minute.
No, so for
One second.
example, if we have RJ45 cable, that
Okay.
top part will be there where it will go in, and the wires are at the bottom, right? So only one side.
How bro? I'll show you.
Ethernet RJ45, for example. Yeah, oh, two side meaning I did not understand.
Yeah, I'll show you. Sure. So this is side one. This is side two. That's
Okay,
all.
end one is what you mean. Okay, two ends. Okay, okay.
You get my point?
Yeah,
So
I
one,
thought
for
on
example, one is
one
you need to
I thought
connect to
on
the
one.
router, and another side you need to connect to the switch. Or
Okay.
one is you need to connect to that switch, and one is you need to connect to the PC.
Oh, okay. I thought in one side, in one part, there are two sides. That's what I was thinking.
No, no. So inside this particular headpiece, okay, we have a 8 color codes. That means 8 copper cables. Okay, each copper cables will have a single color. That means there is a color is there. Okay, see for example here.
Yeah,
So
agreed.
yeah, sorry, what is it?
Yeah, that's fine. Color codes are there.
Yeah. So straight through cable means same color code in the same both side. Like I say, side A and side B, it's in the both side or the same colors. For example, if you see, it will start with white with orange. Here is also white with orange. But
Okay.
when you see this crossover cable, it will start with white with orange, but the side B start with white with green.
Okay, okay.
So
Now it's clear.
why they are changing the
So,
color code?
yeah,
Okay,
this is
because of
yeah, this is for connecting between routers, or from router to modem, or from where to where. Like, what is one end going and where is the other end going?
that is again so that is our wish actually. See for example, you can see here. So if you are connecting different devices, okay, router to switch, switch to PC, switch to server, okay, so anything, switch to hub or anything. So if you are connecting to the different devices, then you need to use the straight through cable. Okay, why? Because in the straight through cable, both port are the same thing. That means here is also we have a this 8 RX. There is a 4 RX pin and 4 TX pin. Okay, the same order in the same other switch is also same order. So if you are connecting the straight through cable, both are in the same color code. So automatically the RX pin will connect to the RX pin, TX pin will connect to the TX pin. You get my point?
Okay, so basically different devices,
Correct.
straight
If
through,
it's a different devices, if
straight
it's
through.
a router, okay, RX pin and TX pin will be in this different order. You get my point? So
Okay.
then that time you need to use a crossover cable because here there is a some other the RX and TX pin will be in the some other order. Here the RX and TX pin will be in the some other order.
Okay.
Okay, so that time you need to use a crossover. Okay, so see here, switch to switch. Sorry, I swapped that. So different devices means straight through and same devices means crossover. Switch to switch, router to router, router to PC. Yeah, why router to PC? Because PC is also the L3 devices like that. Okay, it works under the IP address. It's also something like a router, but not actually router. PC to PC, PC to server. This all we are getting into the same devices. So that time we need to use a crossover. Okay.
So that logic is not there, right? Same to same device, crossover, or say different devices, straight through. That logic is not there here, right? Because there is no consistency in that image, right? If we
Which
check
one
that,
you
if
asking?
we check the crossover image, it is router to router and router to PC as well, PC to PC.
Yeah, see, that's what I'm saying. PC is also something like a router because PC is also works under the L3 network only, right? We need to assign the IP address and all. Okay, so that is also that pin that Ethernet port will be in that particular order only. Okay, so PG is also something like a router only here. Okay, as a design purpose, I am saying.
Okay.
Okay, you are thinking like a router and the PG is a different device, but by design wise, this port which is the same RX and TX pin. Okay, so that is the reason they are using the crossover cable. If you are directly connected from the router to switch, sorry, the router to PC, then you need to use a crossover. But if you are using the router to switch to PC, that is completely different. That is, you need to use a straight through switch to PC. Okay, so again, this all something like a old things now. Okay, so now we have a that feature called auto MDX support. So automatically, if you are using the crossover or straight through, that doesn't matter. The data will be transmitted.
Okay.
Get my point? Any doubts?
Clear.
Okay, so now coming to that error. Okay, so mismatched duplex means, for example, we have a 3 duplex method. One is single duplex, one is half duplex, one is full duplex. Okay, single duplex means there is a only one sender, one receiver. Not a one receiver, there is a only one sender. So, for example, you can say like a TV, radio, this and all, because that particular person sending the information, that speaking everything, but we cannot speak to them directly. So that is called a single duplex. Okay, there is only one sender and receivers. Half duplex means both sides can talk, but at this sorry, so one person at a time. Okay, for example, walkie talkie. So if the opposite person is speaking something, okay, once he said over, then only I can able to talk. So that is called the half duplex method. Third one is full duplex method. Full duplex method is nothing but a cell phone or mobile phone. So at the same time, we can talk to each other. So these are the 3 types of duplex method we have. Okay, are you able to get my point?
Yeah.
So now coming to the networking, okay, the same thing we have a, okay, we have a half duplex method and full duplex method. Okay, not a single duplex, we have a half duplex and full duplex. What is a half duplex and full duplex? If I configure the half duplex for the both device, if that particular switch A speaks, the switch B will receive only. If switch B speaks, switch A will receive only. Okay, but if I configure here the half duplex and here the full duplex, then the issue will rise. Okay, that is called mismatch duplex error. Okay, mismatch duplex error means it will create an CRC error. Okay, inside the interface, it will increase the CRC errors. I will show you inside the packet tracer. I will show you. Okay, and the last one is speed. What is the speed here? For example, I have a switch A and switch B. Okay, both are connected each other. Okay, there is a one PC is connected here and one PC connected here. Okay, every switch we have a different port types. Okay, for example, Ethernet port, fast Ethernet port, gigabit Ethernet port. Okay, Ethernet port means that particular port is capable of handling 10 Mbps per second. Fast Ethernet means 100 Mbps per second. Okay, gigabit Ethernet means 1 gig, that means 1 Gbps per second. Okay, so if you are taking any L2 switches, it should be these 3 types. Okay, it should be Ethernet, fast Ethernet, gigabit Ethernet. If you are going to some data center switches, then we have a 10 gig port, 25 gig port. That means 10 gigabit Ethernet, 25 gigabit Ethernet. Simple. So now if you are go for the L3, L2 switches, okay, I have a switch A, okay, with a port of fast Ethernet port, okay, and the switch P is in the 1 gig port, okay. So this particular system A is trying to send some large data, okay. It will go to the switch to go to the fast Ethernet this particular port, and it will start to forwarding the data. So every single second it will transfer the 100 Mbps data. So this 1 gig port is enough for receiving that, so it will automatically receive that, no problem on that. But at the same time, let's just understand, okay, the system B is trying to send some same data, okay, it's a large data, okay, but this port will transfer 1 gig 1 GB data per second, but this fast Ethernet port is only capable of receiving 100 Mbps, correct? So at the first seconds it will receive 100 Mbps and 900 Mbps of data will be in queue, correct? Because this is sending the every second it's sending the 1000 Mbps, that's the 1 GB, okay, but it will only receive the 100 Mbps, so 900 Mbps of data will be in queue. At the very next seconds it will send the 1 GB data and it will only receive the 100 Mbps. So remaining 900 Mbps. So totally 1800 Mbps of data will be in queue. So if it's keep on happening, then that particular cable it start to leaking the traffic. Then you will see the packet loss. Okay. So as an architecture, okay, so when you are deciding some data center design and all, you need to be ensure what is the device we are going to use, what is the speed, who is the sender, who is the receiver, everything you need to take care, then only you need to design that. Okay, so this is the one type of error. Any doubts?
Um, I understood till the part where you explained about simplex, half duplex, full duplex, and then we started with errors, right? This is CRC, CEC.
I'll show you CRC, okay, but this is for the speed.
No, what
Okay.
error is this? So, for example, here packets are being transferred from one point to another point, and what error is happening? Packet drops is happening.
Packet drops is happening.
Okay.
Okay. So whenever that packet drops or something happening in the issue, that means inside the cables or some connectors, what will happen? One second. So so interface fast Ethernet 0/1. Okay, so whenever there is a packet loss or you can see like any issue in the data, then you will see here where is the here. Here. Okay, so this particular input errors, CRC, frames, this particular, now it's in 0, right? It will keep on increasing. Okay, for first time, if you are giving the command like a show interface fast Ethernet, it will be in the 100, then next time 120, then next time 130. So if it's keep on increasing, then you need to check the cables and cabling port numbers. That means a port errors and all. Okay, and then there is a queues, that input queues, total output drops. So this is also will increase. Okay, so based on this information, you can understand there is some issue in the particular cabling or cable ports. Okay, so based on that, it will you need to troubleshoot. You get me, boy?
Okay.
Okay, so this is for the errors. Okay, and 8 o'clock. Okay, so tomorrow we are going to see some important topic which is IP and subnetting. Okay, so that will take 1 or 2 classes. So and that is also confusing topic. Okay, we'll see that one by one. We will see that. Okay.
Okay. All right.
Any doubts so far?
This error thing I did not understand very well. Like if you can maybe show the example again next class, I can go through it again.
Okay.
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 Yeah. All right. We'll meet tomorrow then. Thank you.
Yeah. Yeah. Sure.